Okay, so the premise of our video is pretty much to answer the question, what's more convenient when going up a hill, walking or biking? So the way we're going to empirically find that answer is through energy, and to find energy we're going to need to do some kinematics. So right here we have V equals delta x over delta t, so we know that the change in position is 0.8 meters, and we know that the change in time is 0.7 seconds. So if we calculate that, we get something roughly of 1.14 meters per second. And for acceleration, we can find acceleration using the velocity we just found. So 1.14 meters per second over delta t, and the delta t here would be the average of the other two times. So it would be 1.2 seconds divided by, 1.2 minus 0, which is 1.2, divided by 2, which is 0.6 seconds. And if we calculate that, we get something around 1.9 meters per second squared. Alright, so now we can start focusing on the energy lens, and previously we were in a kinematics lens. So now that we have velocity, we can start plugging in some equations. So we want to get the total kinetic energy, and the total kinetic energy and the total potential energy. So we know that kinetic energy is equal to 1/2 times mass times velocity squared, and potential energy is equal to mass times the acceleration due to gravity times height. So for kinetic energy we have 1/2 the mass, and the mass of Samantha is roughly 60 kilograms, so 1/2 60 kilograms times 1.14 meters per second quantity squared, and we just found the velocity. And we're going to add that to the mass, and we know that gravity, the acceleration due to gravity, is 10 meters per second squared. And to find our height, I drew this triangle right here. So as you can see, this is the diagonal displacement, 0.8 meters, and we have an angle of roughly 7.7 degrees, which we measured. So we know that the sine of 7.7 degrees is equal to opposite, which is h, over the hypotenuse. So to find h, we would just multiply the displacement times the sine of 7.7 degrees, so 0.8 meters times sine of 7.7 degrees. And if we do the calculations and we add both of these energies up, we would get around 95.46 joules. So now with that information we can find power, and we know power to be the change in energy over the change in time. So we just found the change in energy because we started with 0, so 95.46 joules over change in time, which is 0.6 seconds. So if we calculate that, we get 159 joules per second, or 159 watts. And this energy and this power is for one step, so we would just keep adding for each step, and that's how we would find the total energy and power required to climb up the entire ramp.